This video is to help you a little bit with the analysis for the stopper lab. But I'm actually going to back up. I'm not going to do the analysis questions yet. I'm going to back up to the procedure. And step 10 of the procedure says to draw an overhead view of the swinging stopper, including vector arrows to show direction and magnitude of velocity, acceleration, and force. And that sounds really complicated, but it's way, way easier than it sounds. So an overhead view of the swinging stopper. So if you were swinging the stopper in a circle around your head and you were to look down from overhead, what would it look like? It would be making a circle. We could mark the center, and then there would be a string. Just like that. Okay? You can even draw the stopper in if you want to. I would suggest that you add an arrow showing which direction your stopper is moving. So if it's going this way, draw a little curved arrow and just label that motion. And now we want to do vector arrows to show tangential velocity, centripetal acceleration, centripetal force. So if this is our stopper here, then our velocity, if it's moving this direction, remember that tangential velocity moves perpendicular to that radius. So our velocity arrow would go this way, VT. Centripetal acceleration and centripetal force are both directed inward toward the axis, the center of the circle. So we can draw another arrow here and label that as force, FC. We can also label that as acceleration. Well, what if the stopper was over here? What would our arrows look like? Well, our tangential velocity is still going to be perpendicular to that radius, and if it's moving in this direction, then our velocity arrow is going to go that way, VT. Force and acceleration are still always, always, always pointed toward the center. So force and acceleration. And that's it. That's really all I'm looking for. The first analysis question is explain how centripetal force and hanger weight are related. Well, I'm not going to tell you the answer to that. I just want you to think about them a little bit. So what is centripetal force? Go back to your notes. What is centripetal force? It is something applying a force to an object that keeps it spinning in a circle or moving in a circle. So in this case of swinging a stopper on a string around your head, where does that force come from? It comes out of the string, but where does the force in the string come from? Think about that. The next question is about percent difference or percent error, and these may be flipped on yours, and that's okay. So hanger weight minus centripetal force divided by hanger weight times 100. So whatever your weight is, 0.98 newtons for me, minus our centripetal force. Hopefully yours will be a little bit closer than that. And then divided by our hanger weight again, and then times 100. So I like to hit enter in between all of my steps just to make sure that my calculator understands what I'm doing. So 0.98 minus 0.41 equals divided by 0.98 equals times 100. So I got for trial 1 58.16% error. Hopefully yours is a lot smaller than that. If it's this big, go back and double check your math one more time, because hopefully it should be better. And the last question, 2 sources of error that are not related to calculation mistakes. So if I got an error of this, 58.16%, and I looked at that and I thought, that's really big, but oh well. I could say, well, maybe I calculated my force wrong here. But no, that's a mistake. If you think maybe you calculated something wrong, stop what you're doing, go back, redo all of your calculations. That's never a source of error. Okay? If you, well, maybe I didn't convert one of my measurements. Okay? Stop, go back, convert your measurements, recalculate everything. Those are both mistakes. Those are not sources of error. Remember, in science, an error is something that has an effect on your results that maybe you couldn't necessarily control given the situation. So that's what I'm looking for sources of error. Something more specific about the equipment, the setup, what the room was like. This is not one where the air conditioner blowing on you is going to make a difference. If your arm is cold, that doesn't really affect the velocity of your stopper. So think a little bit deeper. Think about the equipment itself. Think about the way that measurements were taken, the way that calculations were done, and see what you can come up with. I hope that helps.